So our next speaker is me. We're going to talk about the new capability. So here on the screen we've got, the lights aren't on today. We have 8 capabilities. This is I guess the second one that we've released. So we're going to present it first, naturally. This is called Automated Ingest. This is actually a Python module that uses the Python iRODS client to speak to iRODS. And I'm going to hide the rest of my stuff here. So there are no slides for this talk specifically because it's just a GitHub repo. I want to point out that the idea behind these things are that they are more standalone and don't require as much hand-holding or knowledge or writing of rules or reading the entire internet to make them work. The idea is that these pieces of software you will be able to download and either install and then configure, but not have to know how it works, right? You can configure the knobs to make it do what you want. So the talk itself really is about scrolling down slowly and showing you the README. It's the worst of presentations. So, also it's early. So this automated ingest framework came from hearing stories from all of you about what you wanted to do. And there were basically 2 main use cases where people showed up and wanted to be able to get lots of data into iRODS, right? The 2 use cases are, I have a lot of stuff, I bought a company, there's lots of data that they have and we need to get it into our existing system. So mostly that's a registration use case, right? We don't want to move the data, we're perfectly happy where it is, but we want to get it into iRODS so that we can talk about it, annotate it, maybe move it later, do something official with it, but we want to keep track of it. So that's the first use case. That's the file system scanner. No, that's not true. Yes, it is. That's true. All right, file system scanner. The second use case is not about registration, but actually about ingest. We want to move the data and get it in. So that's when things come off of instruments or satellites or sensors in the ocean or sequencers, right? It's new data being generated that needs to be pulled into iRODS for the first time. So it needs to be put and then registered, right? So the idea behind this framework is that we have captured these particular use cases with a set of operations. We've got registers, we've got puts, we've got syncs so that you can run this in a recurring manner to keep track of things that are changing. And then I'm going to hand this over to Hal, who's going to demonstrate this along with something else. It's pretty standalone. It solves the things that we've heard from you guys. And Monty actually stood up yesterday and showed some of the configurations that he did for this and for the storage tiering, which is going to be next. I think we can switch screens. And Hal can do a quick demo of how this how this works. It's good. It's so early. And I'm going to hand this to you. Is that the right way?
Yeah. Actually, let me see what will be a good angle for me to be able to see that screen.
Oh, because you can't see that screen.
Yeah. Okay.
Here, I'll talk and you type. Right. How about that? All right, this is great. So what you're seeing is a terminal that may be big enough. Can you read it? No. Yes. Not really. If Hal can't read it, it's not going to work. So the problem is that you can't see the screen while you're typing? All right. So this Python tool, the idea behind it is that we can ingest things in parallel. We always had iReg, right? iReg is serialized, right? It's going to ingest things. It's going to do a tree walk of whatever it is you pointed at, and it will pull things in. It can do it recursively. That's great. But it's going to be serialized, and it's only going to move at the speed of that one CPU reading the disk. It'll get there, and it's restartable and rerunnable, but it's not in parallel, right? It won't keep up with things that are fast or things that are too big to not take 6 months. We had a case where, yes, let's run that. It's going to take 4 months to catch up. Okay, that's not a solution. So this is built and designed around Redis queue. So this Python tool can be run on many machines at the same time, sharing a Redis backplane, which means that they're all writing down the status of what they've scanned, the age, the size, all the information about the file. That's how the tool determines that something has changed for that sync situation. Obviously, the first time it sees something, it's new, and so it goes ahead and tells iRODS that it needs to do some work. But if you run this against a large system that's changing, now the idea is because of the shared Redis backplane of all the number of scanners that you're running, you can scale up. You can just dial up the number of computers that are running this, the number of CPUs, to keep up with and have a bunch of Redis workers that are keeping up with the scanning system, right? At that point, the limitation will be how fast can you write to the catalog, right? But the scanner only needs to talk to the catalog when things are actually different, right? So that first scan is going to be a beast, right? But the idea is that you can keep up with a fast-moving file system after the fact, but only tell iRODS, only need to have chatter to talk to iRODS when it detects new files that are changed, or new or updated files. So what Hal has got on screen now is some windows that have the scanner running. Well, he's going to have that once he turns it on.
What we're going to do is, I'm going to type my command. When I type my command, I have to drag onto my screen.
Oh, goodness.
Thank you. So first of all, I'm gonna start a window that kind of watches the. Can we have the screen, please? Yeah. So I'm here. I have four panels in this window. So on the top right corner, I'm starting a watch command to watch all the pods living in this Kubernetes cluster. This is just a one node cluster I set up on my workstation, but we're in the process of building a 5-node cluster at Renzi. If you see the next demo, it's likely to be on that cluster.
So he used a new word, Kubernetes. I didn't mention that yet, right? So there are multiple ways to deploy this system right now. One is manually, which is the way that I've done all the proofs of concept in the last few weeks that are using this tool. We determined that that's a lot of work, and it requires typing in a lot of little windows, and your environment variables have to be just right. So the next thing is to be able to use Kubernetes to deploy this, or to be able to basically Dockerize everything and then use Kubernetes to deploy this in a way that you can just dial up or dial down the number of workers that you want, number of machines that have the workers. And then the super backflip advanced move is going to have a Helm chart that can control the Kubernetes, that can control the Python ingest tool, right? So now you've got a hands-free environment that will supposedly keep up with whatever you throw at it, irrespective of what iRODS is doing, right? This is about watching a file system. Go for it.
Okay, now I'm going to run, I've already run one Helm command. I'm going to run 2 more. So these 3 Helm commands will deploy an iRODS. By the way, this iRODS is running with CockroachDB as its backend. The second Helm
it's another surprise.
The second Helm, we can also run Postgres, but that's not interesting, right? This is the more interesting use case. So you use one Helm command to deploy the iRODS with Cockroach backend. So if you look at the top right corner, when it's done, it should say it's done. Then I'm gonna run the second Helm.
All right, don't run it until you put it back on the screen, until you slide it over. It's too late. All right.
All right, so the second one actually already running.
But don't hit enter until you slide the window back over so they can see what you're doing.
Okay, so I'm gonna. Okay. So this tool, the deployment is pretty fast, but I do need to wait for it to finish. So what this tool does is, what the section helm chart does is basically deploying what Terrell was talking about. And okay, it's running.
They don't believe you. All right, don't hit enter. Don't do it.
So now, if you look at top left corner, I already put the command on command line. If I hit enter, now it is deploying the dashboard, which I will show you, that will show you the activities in a graphical user interface phase.
Do you see it?
Pull a rabbit out. Okay, so. Okay, so now I'm going to open the Google Chrome, and I'll show you the Google Chrome on the other screen, and you will be able to see a dashboard. I need to log in first. Okay, I'm gonna log in. No, it's hard to see where to type on that screen. Okay, so I'm logged in, and I'm going to, because this is through the SSH X forwarding, so it takes some time to load the whole thing.
He's hitting port 8000 on the local machine that's running the Kubernetes machine. And for some reason, we're going through X Windows. I'm watching his screen scan as it updates the pixels. Yes?
This is the X forwarding, that's the, okay. All right. Okay, there we go. So this, okay, so this on the top here, you see there's activity of the ingest tool. On the bottom, it shows you the activity of iRODS, and here, if there's any error, it will show on the right-hand side. So what I'm gonna do is I'm gonna just put one file, and
yeah, you can just do it on this screen. Yeah. Okay. So from one of his bottom right terminal, he's just going to put, he's touching a file.
yeah, I'm just cutting a file.
And so because the scanner is running, it should pick up that new file on the existing file system, right? So within, I don't know, however many seconds it takes for X Windows to update, you should see a blip, right? So we tried to run this on, so this right now is running on Minikubes, is that right?
Yes.
Yeah, so this is Minikubes on a single machine. What that means, if you don't know these words. So Kubernetes proper assumes you have real hardware and that you have real networking and you're deploying real things to real things. Minikubes is for testing or to prove out your workflows, and it all runs on one local machine and then pretends that it has real hardware everywhere. So we had 5 machines down in our cluster downstairs at Rensi. We launched this and ran into mount point permissions and all kinds of stuff. When you have real things, it turns out it's harder. So the demo is in Minikubes, but it does the same controls and same settings will work for those of you who also have real clusters if you want to play with this.
Okay, so now you see this is the file I just put into a synchronization directory. And this shows an activity in iRODS, and here it says register file. So the iRODS just registered that, the automated ingest tool just registered that file into iRODS. And on the top, you see that that's the scanning activity. So the blue is scanning the directory, and the green is scanning the file. So if you have errors, it will show in a different color, and you show in the right-hand side. So that's the demo.
Right. So you can see both what information is being scanned, but then you can also see the activity going into iRODS, right? And this is completely independent of, say, the auditing tool picking up the fact that iRODS was doing stuff and emitting all the messages and all that kind of other stuff that we talked about yesterday. You can see concurrent users. This has nothing to do with that, but the charts look similar because they're time series data, right? So I think we did it. Good job. Thanks, Hal.